Good morning, everyone. You guys can get out a fresh sheet of paper and something to write with. And our topic today is adding and subtracting fractions. That's what we left off on. We had done quite a bit of practice on this before we all left. And it's been a little while, so I thought the first week would be a little bit of a recap for that which we were learning. It's important to note that it does look a little different, and this is kind of what you'll see, just me writing notes on a piece of paper. That's what we have for now, and it's not that bad, I hope. So, to begin, we'll kind of start with the basics. We'll do a few examples, and then you guys can have some practice. Our first example, keep it somewhat simple. One third subtract 2/3. It's good to note that 2/3 is bigger than 1/3. I'm taking that from 1/3. Therefore, before even doing any kind of calculations, I can always just kind of guess what my answer should be. And in this case, it should be negative. 2/3 is bigger than 1/3. I should go into the negatives. Now, normally we have to find a common denominator. That's already here for us. They're both 3, so we don't really have to do anything in that sense. So, what's 1 subtract 2? Here we have negative 1 over 3. And I can write it like that, and that represents the fraction. That is 1/3 subtract 2/3. I can put the negative up top with the 1, that's okay. Other times you'll see it just right out here in front of the fraction. It's not really with the 1, it's not really with the 3, it's that the whole fraction itself is a negative number, and that's okay as well. Next up, we'll do 2 plus 4 over 5. Now, this one looks a little different, but it is actually kind of simple. This is something you really don't quite have to think about. This is 2 and 4/5. Sometimes we say and for addition. So 2 and 4/5 we can also write like a mixed number. It is 2 and 4/5. However, the next example, it's harder to do something like that. 2 minus 4/5. So here we can kind of say, okay, we have 2 and we're subtracting 4/5 from it. We're subtracting something that's not quite 1. So our answer should be bigger than 1. So every now and then we got to do that guessing of what our answer should be, just to make sure we're on the right track. So if I take 2 and subtract 4/5, it's a little more difficult to just do like I did up here. However, I can change the 2 to be something that looks a little different. However, it's the exact same number. If it's over 5, I'm going to say 10 over 5. Because 10 divided by 5 is 2. Then I'm going to minus 4 over 5. And what I have essentially done is found a common denominator. So that'll leave me with 6 over 5. I really need the equal sign here. So 6 over 5 can be converted to be 1 and 1/5. It's a little bigger than 1, just like we thought. So let's go with second set of examples. 3 over 7 plus 4 over 5. Because these things have different denominators, they're entirely different entities. And I have to find a common denominator in order to actually add them together. So we can think about maybe trying to scale one of them up or down, but that simply just doesn't apply here. It's not going to work. And so we can take the two bottom numbers and just multiply them together. Sometimes it's nice to do that on the side. 7 times 5 is 35. Even writing it down allows you to begin to process that which you're trying to do. So 7 times 5 is 35. So both these fractions are going to be out of 35. Okay, so I take a 7 and I multiply it by 5 to get 35. So I'll multiply a 3 by 5. That's 15. I took a 5 and I multiplied it by 7. See, the 7 I multiplied by 5, but the 5 I multiplied by 7. So then the thing on the top I have to multiply by the same. 5 I multiply by 7. 4 I multiply by 7. I get 20, followed by adding them together. So 15 plus 28. 28 plus 10 is 38. 38 plus 5 should be 43. So we have 43 over 35. Yeah, that makes sense. Okay, so that's our end result. That's what we can leave that as. If we wanted to write it like we did up here as a mixed number, we could say 1 and 8 over 35. Let's try another common denominator one. 2/3 minus 6 over 7. So, can't scale one up or down. So 3 times 7 is 21. So both of these are going to be out of 21. So I have something out of 21 here, something out of 21 here. I'm subtracting them. So I multiply the 3 by 7, and so I should multiply the 2 by 7. 14 out of 21. 7 by 3 is 21, so 6 by 3 is 18. 14 subtract 18. Okay. First and foremost, we know it's going to be out of 21. 14 subtract 18 is negative 4. So I'll write it like this. It's going to be a negative fraction. It's on the other side of 0. The negative side of 0. And that's what we would have for our answer there. Every now and then, actually throughout this process, I'm not really mentioning it, but I am asking myself, can any of these fractions be reduced? And, well, 4 can be divided by 4 and 2. 21 cannot nicely be divided by either of those numbers. So this is the lowest form of the fraction. Let's try one more common denominator. Let's see. Do 22 over 7 plus, let's change it up a little bit. Let's say plus negative 16 over 3. We know how to add and subtract integers. There's no reason why we shouldn't be able to do this. But we want to ask ourselves the question, well, can we add these together in the first place? No, not really. Need a common denominator. Now, luckily it's 7 times 3. It's the exact same denominator we did up here. So we already know what we're trying to make this thing look like. So we have something over 21 plus a negative fraction that's also over 21. Let's start with the first one. I multiplied the 7 by 3 to get 21, so I gotta multiply 22 by 3. 22 by 3, that's 66. And so 3 by 7 is 21, so I have to multiply 16 by 7. So 16 times 7. 16, 10, and 6. I multiply both of those by 7. So and then combine them back together again. 112. So that's 112 over 21. Okay, so they're both over 21. I'm going to add them together, but one's negative, so there's going to be some cancellation happening here. So I have 112 that's negative, 66 that's positive, and what would that be to? Well, I think 34 gets me to 100. 34 plus 12 is 46. And it's negative because the 112 is bigger. So we should have negative 46 over 21. So now I gotta ask that question, can this be reduced? Can I divide any of these by the same thing? Well, I can divide 21 by 3. That'll give me 7. And divide 46 by 3. I think it may be, because it ends in a 6. It turns out I can't. So I can't actually reduce this. Thought maybe, realized it couldn't, and that's okay. We'll try a few more examples here. Flip over. Go for example 3. And let's throw in some mixed numbers. Let's do 3, 4 over 5, plus 2.5. Now we recall how to do this. All we have to do, first and foremost, is let's just do 3 plus 2. That's 5. So 3 plus 2 is 5. So I'll just kind of like my accounting over here. 3 plus 2 is 5. Okay. That gets rid of that takes care of the kind of standard number here. And now all we have to do is 4/5 plus 1/2. And this 5 is going to be important, but it's really important that we don't claim this is going to be 5 and something, because it depends on what the fractions add up to. And you'll know that 4/5 is really close to 1, and half is half of 1. So something really close to 1 plus a half should be greater than 1. And so in order to do this, it's exactly like the other examples. We need to find a common denominator, which is 10. So this is going to be 8 over 10, double that, plus 5 over 10. 5 is half of 10. And add them together, I get 13 over 10. Okay, that is 1 3/10. So altogether I have 5, and I have 1 3/10. hope we understand where the 1 comes from here. So 13 over 10, I mean, we can break it up into 10 over 10 plus 3 over 10 because same denominator. I mean, it's all the same stuff, so 10 plus 3 is 13. And 10 over 10, that's actually our 1. 10 divided by 10 is 1. So I have 1 and 3/10. In case we were unsure of where that came from. So now I add that to my 5, which is the 3 plus 2. So all together, I have 5 plus 1, that's 6. And 3/10. And that's my answer. That's it right there. Okay, we'll do one more mixed number example. This will be a little different. We're going to pull any punches here. 7, 6 over 7, minus 3 and 2/5, and actually, let's make that 3 and 2/5 negative, just for fun. Okay. Now, there's going to be a few different ways we can do this. I like the idea, in this case, of just changing this whole thing to an addition statement, because we have to recognize that we are subtracting a wholly negative number. So I'm gonna change this. I don't quite know why I wouldn't. And right off the bat, this seems a little bit different, maybe easier. It actually seems a lot like the thing we did up here. So it's the same recipe. Alright, well, let's follow that same recipe. 7 plus 3 is 10, so we got that. And then we got 6 over 7 plus 2 over 5. I'd say this is going to be greater than 1. We'll find a common denominator of 35, because that's 7 times 5. Okay, multiplied the 7 by 5, I gotta multiply the 6 by 5 to get 30. Multiply the 2 by 7 to get 14. Add them together, 44 over 35. That changes to 1. And 9 over 35. So I have all together, now I'm going quite quickly, but I have all together 11, that's the 10 and the 1, and 9 over 35. And I could reduce the 9 over 35, that could be 3 over 15. If I divide both by 3. Just kidding, that's not true. Can't divide 35 by 3 to get 15. I don't think I can divide it by 3 at all. No. So, that's done. I think that's lowest terms. Yeah, 9 can only be divided by 3 and 9, and 35 can't be divided by either of those. Yeah, let's do one more. So, let's do one more that we missed. Let's do 1, 5 over 7, and that's going to be negative. Whole fraction is negative. Whole mixed number is negative. And we're going to subtract 2/3 from it. Okay, so the reason I want to do this is because what are we gonna try and do here? Actually, I think the best strategy to use here might be to actually just fold this whole thing into an improper fraction. So 1 times 7 is 7, 7 plus 5 is 12. So 12 over 7, negative 12 over 7, subtract 2 over 3. So common denominator would say 21, and we would have 36 over 21. It's negative, subtract 14 over 21. Looking at this, confident in saying that we have a negative number and we're taking 14 from it. We have negative 36, take 14 from it. So I'm negative, and then I'm taking away from that. So I'm going to be more negative. In that sense, we should have as our final answer negative 50 over 21. And I can write it like that, or like so. Either one works. That'll be our last example for today. Let me know if you have any questions with any of the practice, and good luck, and keep healthy.